This looked like a standard optimization question, right, to find the maximum volume. So many of us will write the volume as V equals to 2x squared times height, which is not wrong. And most students see this. And what they do is immediately they start to differentiate. But this is exactly where most students lose marks. Now, you cannot optimize when you still have two variables. So if you want to differentiate now, you are doing it wrong. Hello everyone, welcome back to Olsen Cafe. In this video, I will walk you through what is the correct way of solving this question. So here is the question. There is a rectangular box, has a total surface area of 4,800 centimeters square. The dimension of the box are x, 2x, and h centimeters, and we are to find the maximum volume. As we can see here, we are able to express the volume as V equals to 2x squared h. Now, as mentioned earlier, we cannot start to differentiate at this point in time. It is simply because there are two variables, which is x and h. So when there are two variables, what we need to do is to express the volume in terms of x. And to do this, right, it comes from the total surface area. To express the volume in terms of x, we must first able to express the height in terms of x. So what we do have is, it is given that the surface area is equal to 4,800 centimeters square. So let us form an equation using this information. So to find surface area, as we can see from this rectangular box, for each surface, there are two of such. So therefore, we are going to start off with 2 times of the surface that we can see here. So the first surface that we have is the top surface here. So it's simply 2x squared. Then we are going to add on to the surface right in front, which is 2x times h. And then we will add on to the surface area on the right, which is equals to x times h. So this is equals to 4,800. So what I am going to do is to simplify this equation. So we are going to have 2x squared plus 3xh, and this equals to 2,400. And I'm going to manipulate this. Alright, this will give me 2,400 minus 2x squared, and eventually I will be able to get 2,400 minus 2x squared divided by 3x. Now that we have expressed h in terms of x, we are ready to express the volume in terms of x. So we simply need to substitute h into the expression for v. And once we do that, we are able to derive v equals to 4,800x minus 4x cubed divided by 3. Now that we have the equation with one variable, which is x, we are ready to find the maximum volume, which means we will need to find the derivative dv dx. Yeah, so you can simply leave the fractions like this, or you can just split the two fractions into two fractions so that you can differentiate easily. So I will get 1,600 minus of 4x squared. Now we also have learned in the earlier unit that to find the maximum volume, which is the turning point, all we need to do is we need to set dv dx equals to 0. And what we have here is we simply will get 1,600 minus 4x squared equals to 0. And this is a simple equations that I can easily solve for x, which is equals to 20. Now that we get x, are we able to find volume? It's not difficult, isn't it? We just simply going to work it out, sub into the volume. All right, so work on it and leave in the comments below what is your answer. Now, the final question that I will leave with you is this. We have now found the volume. How do we know that this volume is indeed a maximum volume? Yeah, so do think about it and leave in the comment below how would you do this step. So therefore, in this lesson, the key takeaway over here is that when you have an equation involving two variables, you cannot straight away differentiate, right? We must have an equation, right, with only one variable. So this is something whereby we need to take note before we start to find the derivative. Thank you for watching this video. I hope you found this useful. If this helped you, please like and share the video. See you in my next lesson. Bye.